Hi! This deck of cards was compiled to facilitate working through the MCAT-style passage, Purification of Caffeine. And the content within them is going to be phase change diagrams and hybrid orbitals. So get ready. All right. A phase diagram shows how the phases of a substance are determined by its temperature and external blank. So what two factors determine phase change? Temperature and what? That's right, you guessed it, pressure. So if you just look over to the bottom right, you'll see a phase change diagram showing the solid phase, liquid phase, and gas phase. And so a phase change diagram has temperature on the abscissa, the x-axis, and y on the pressure on the ordinate. And so you can think of phase as being a dependent function, but it's dependent on temperature and pressure. Okay, usually when you see a coordinate plane, the y-axis is dependent on the x-axis, but you can think of phase as being a third dimension, like a z, and that's dependent on both the x and the y. I might have said just now, though, well, yeah, the y-axis is usually dependent on the x, but not in this case, not when it comes to phase at least. All right, when a higher or lower external pressure is applied to a solid undergoing sublimation, the solid would be more likely to change into a liquid before changing to gas. So is this when there's a higher or a lower pressure? That would be a higher pressure. So if a higher pressure is applied, a substance of interest won't just go from, solid to gas. If you increase the pressure, it might go through a liquid phase and then go to gas, which is what we're conceptually more comfortable with. So if you want that to happen, you would just have to increase the pressure. sp2 hybrid atomic orbitals have a blank geometry. What type of geometry do sp2 hybrid orbitals have? And sp2 is basically going to look like something like, with like a circle divided into sections or arcs of 120 degrees. So let's say you have a carbon, that's sp2. It would look something like this. Is going to be the visual for the geometry. And these arcs or angles measure 120 degrees. So what would you call this kind of geometry? Let's say you can have like a, oh no, let's put a methyl over here. So now that's like an aldehyde, I think. Yeah. So that's a trigonal planar geometry, okay? sp3 hybrid atomic orbitals have a T-L geometry. What type of geometry do sp3 hybridals have? I said hybridals, hybrid orbitals. I guess hybridals could be shorthand for hybrid atomic orbitals. Because I'm somewhat of a lazy thinker, my brain automatically shorthands everything, even the enunciation of long words. So sp3 looks something like this. The classic case of sp3 is usually like a methyl. What do you call this geometry? And we're referring to the bond geometry here, not the electron, geometry. That would be a tetrahedral geometry. So that's a tetrahedral geometry, okay? sp hybrid atomic orbitals have a L blank R geometry. So sp could be like a nitrile functional group where carbon triple bonded to nitrogen, and then the angle from one to another is going to be like 180 degrees. Well, it is 180 degrees approximately. So what's this geometry called? That's a linear geometry. Sublimation is a P blank transition. What type of transition is sublimation? It's a phase transition or a phase change. Same difference.